12-4 problem solving strategy, make a model or a drawing. And in this lesson, you'll learn to solve problems using a model or a drawing. Why is it important? Because making a model or a drawing lets you see the problem clear and solve it easier. Okay, so let's take a look at this example. In pet care, June has attached a 20-foot rope to the corner of a 10-foot by 10-foot shed to tie up her horse Harry. How much grazing area does Harry have? So if you notice, without drawing, it is difficult to find the area or even visualize the shape of the horse's grazing area. So many problems, especially those that involve geometry, are easier if you could make a model or a drawing. So let's take a look at this example. What do we know? We know that the dimensions of the shed and the length of the rope, you need to find the grazing area. So let's say this is June's shed right here. Okay, so this is the shed. Okay, and she said that she has attached a 20-foot rope to the corner of a 10-foot shed. So this is our 20-foot rope. So that's the corner. She attached a rope 20 feet long. So when you talk about the grazing area of Harry, let's say Harry is attached to the end of that rope. Harry can graze. If she pulls the rope all the way down to 20 feet, she can graze this, he can graze this area right here, which is 10 feet right there. Okay, so Harry can move from this area to this area. Okay, let's see if I can enlighten that thing. Okay, all the way to the corner right there. So, and also Harry can move to the other area right there. So the 20-foot rope, Harry can move on both sides to that area right there. And if you notice, it creates a this one. This shape creates a 3/4 circle. So this particular shape right here, okay, right here, right there is actually 3/4 of a circle. So that is 3/4 of a circle right there. Okay, so it's we're not done because after Harry, let's say, grazes that area, that corner will catch the rope, and she will have, or she he will have a smaller grazing area now. So when Harry reaches this part of the shed, he will have a smaller area, which is that one. And if when Harry reaches this part of the shed, the rope it catches the rope, and Harry will have this part of the grazing area. So this is the total grazing area of Harry. So what we want to do, we want to make a drawing to illustrate the problem. Notice that you have sections of circles. The largest section is 3/4 of a circle. This one right here, we talked about that, with a radius of 20 feet. The smaller sections right here, okay, the smaller sections are 1/4 of a circle with a radius of 10 feet. So that's your radius, okay, 10 feet, not anymore 20 feet. So you can find the areas and the areas of each section and add to find the total grazing area. So what our plan is, we want to find the area of 3/4 of this big circle and the area of these two 1/4 circles, add them up to be able to find the area of our grazing area right there. Let me take this out. I don't know why this is there. There's something there underneath there. See if we can take that out. There you go. Now we can see it. Okay, so the area of the large section, okay, will be 3/4 of a circle. Okay, which is pi equals, let me take that out again. Oopsie. Delete that. And this is blocking our path now to what we want to do. Okay, let's delete that now. Okay, there we go. So the area of our large section, which is A equals pi r squared times 3/4. Why multiplied by 3/4? Because we only have 3/4 of a circle, not a full circle. Okay, so first we estimate, okay, 3 times 400 times, okay, 3/4. Our area should be close to around 900 square feet. Okay, so let's find the exact area. Substitute the values. Our radius is 20. So we have now pi times 20 squared times 3/4. Okay, and multiply all of them, end up area equals 942 square feet. So close enough to our estimate, so we're good with that. Okay, and then we want to find the area of these two circles. Okay, remember, if you add up the, sorry, not these two circles, these two 1/2 circles right here. Okay, this is a 1/4 circle, and this is another fourth of a circle. And if you notice, if you add a 1/4 plus 1/4, it adds up to 1/2. Okay, we'll take care of that later. But right now we need to find the area of this 1/4 of a circle. Okay, these 2/4 of a circle. So to be able to find the area of the smaller section, again we follow the formula pi equals r squared, but instead of multiplying it by 1/4 now, we simply multiply, sorry, instead of multiplying it by 3/4, we simply multiply it by 1/4. Substitute the values, the radius has changed. Instead of 20 feet, the radius of this particular fourth of a circle would be 10 feet. So pi times 10 squared times 1/4 gives you an area of around 79 square feet. And if you notice, if you estimate it 3 times 100 times 1/4, okay, our area should be close to 75 square feet, which is very close to our exact answer. Okay, so the total area where Harry will be grazing will be the sum of the 3/4 of a circle, which is 942, times plus 79, okay, and multiplied by 2, because there are two 1/4 circles right here. Okay, so multiply 79 by 2, that'll be 1100. Okay, so the horse has a grazing area of around 1100 square feet. Okay, now if you notice, the answer 1100 square feet seems reasonable compared to our estimates. Okay, so that's how you find, that's how you solve this problem, by drawing, okay, to see exactly how you are going to solve this type of problems. Now let's take a look at this, think about it. How do you know that the large section is 3/4 of a circle and the small sections are 1/4 of a circle? Okay, that's a question you should be asking yourself. Basically, the answer is the building corners are 90 degrees right there. Okay, and the circle has 360 degrees. So if this is 90 degrees right here, okay, that means 1/4 of the circle is missing from this 3/4. Okay, and that's how you find and know that you have 3/4 of a circle. So that's how you do that example with Harry. And let's take a look at additional examples in the guided practice. Okay, now let's go back to the same problem at the beginning of the lesson. Suppose the rope is only 15 feet long. Find the grazing area. So again, instead of 10 feet, instead of 20 feet, the grazing area now will become only 15 feet. So this becomes 15 feet instead of 20 feet compared to the original example we had at the beginning. Okay, so if that's the case, we want to find the area of the large section. And in order to find the area of the large section, again, we use pi r squared times 3/4. Okay, but instead now of a radius of 20 feet, we have a radius of 15 feet. So we have area equals pi times 15 squared times 3/4 of our circle. Okay, multiply all of them, we end up with area equals around 530.1 square feet. Okay, that is the area of 3/4 of our circle, and this is our area again. Okay, so this one is what we're looking for right there. This is 3/4 of our circle. Okay, so from there we try to find the small each small section, and remember, each small section is simply 1/4 of the circle. So this is 1/4 of a circle. This is also 1/4 of a circle. Now remember, the rope is only 15 feet. So if this is 10 feet, okay, there will be 5 feet here. So this will only be 5 feet, 5 feet, and the radius now, instead of being 10, will only become 5. So again, we use the formula pi r squared times 1/4, because this constitutes 1/4 of a circle. Substitute the radius, which is 5 squared times 1/4, okay, will now give you pi times 25 times 1/4, simplify that, you end up with the area is 19.6 square feet. Okay, so the grazing area is adding the 3/4 of a circle, which is 530.1 square feet, plus 2 times 19.6. Why? Because there are two 1/4 there, or about 569 square feet. Okay, so that's how you find the answer for that particular example in the case of Harry. Okay, let's see if I have another example. Okay, let's take a look at this example in framing. This is guided practice number 5 on page 630. So let's take a look at this one. Now this is a different type of a problem. Remember, we are still creating a drawing or a model for us to be able to solve a problem faster and easier. So a painting is 15 centimeters by 25 centimeters, is bordered by a mat that is 3 centimeters wide. The frame around the mat is 2 centimeters wide. What is the area of the picture, including the frame and the mat? So it's so hard to find the area if you cannot visualize what you're looking at. So we want to draw this out. If we draw this out, this is how it should look like, our problem. You have a painting that's 15 by 25 centimeters, and it's bordered by a mat which is 3 centimeters. So right there is 3 centimeters. Okay, the frame around the mat is 2 centimeters wide, right there. Okay, so it's asking what is the area of the picture, including the frame and the mat. So you want to find the area of the entire of the biggest rectangle. Okay, so what we want to do, okay, we want to find the length. The length is 25 centimeters, which is this one, plus 3 centimeters. Okay, why is it 2 times 3? Because there's 3 centimeters here, okay, and there's also 3 centimeters on the other side. So it's 25 plus 3 plus 3, or 25 times plus 2 times 3. And if you notice, there's 2 centimeters here, and there's 2 centimeters on the other side, and that's also the reason why it's 2 times 2. Okay? So, if you add them all up, the length of this particular, the biggest rectangle, will be 35 centimeters. And let's try to find the width. So doing the same method as we did in finding the length, the width is 15 centimeters. And then we add the 3 on this side, okay, and the 3 on that side. So that's 2 times 3. So 15 plus 2 times 3. Plus again the 2 on this side and the 2 on that side, which is 2 times 2, will be 25 centimeters. And from there, it's easy to solve because we're trying to find the area of that rectangle. We simply use the formula area equals, okay, length times width. Area equals length times width. Our length is 35 centimeters. Our width is 25 centimeters. So our area now is 875 square centimeters. Okay? And that's how you use models and drawings to be able to solve a word problem such as these. Okay? The secret word for this particular lesson would be thunder. The secret word would be thunder. Thank you for watching.